Hey everybody, and welcome to this video where I want to talk about objects in higher dimension, or more specifically 4 spatial dimensions, and how we can visualize them in a very straightforward and simple way. And shout out to Norton at the University of Pittsburgh and his article online, which has helped me formulate this. And so we can think about higher dimensions using the Hypercube family. The Hypercube, let's put this in white. The Hypercube family. And the best way that I found to do it, to understand it, to conceptualize higher dimensions, is to start from the beginning. So we're going to start with 1 dimension. Okay, so 1 dimension is really just a line segment. So for example, we have a line, and this line segment is considered 1-dimensional. If we wanted to move to 2 dimensions, all we have to do is create 2 line segments and connect them. And we then have a 2-dimensional visualization, a 2-dimensional object. And this object, if we connect the 2 line segments, would be what? A square. This would be a square. And this is also considered a polygon. So we have a square, we move from 1 dimensions to 2 dimensions, and now we want to go to 3 dimensions. So now we want to go to 3 dimensions. To get 3 dimensions, let's keep this consistent here. If we want to go to 3 dimensions, all we have to do is connect 2 squares. So here's square number 1, and here's square number 2. And then if we connect them, we get a cube. And we are familiar with cubes in 3 dimensions. Boom. So we move from 1 dimension to 2 dimensions to 3 dimensions, and all we did is connect the 2 lines to get 2D, and we connected 2 squares to get 3D. And I think you guys might be getting where I'm going from here. To get 4-dimensional space, 4-dimensional space, all we have to do is connect 2 cubes to form what we call a tesseract. Let me give ourselves some room here to get a tesseract. And so we have 2 cubes, and I'm going to draw these cubes from a different perspective than this one. This one we're like slightly to the side and we can see the side of the cube. But these cubes we will not be to the side. We will be looking straight forward. So here is a cube. And if you think about it, you can think about this as like a giant room, right? Here's the floor, here are the 2 side walls, the back wall, and the ceiling, right? This is a cube. Now we can draw another cube. Same as before. But now we need to connect our cubes to get our tesseract, which has been used in movies for fancy stuff. And it gets difficult to visualize as I connect these dots. But remember, all we are doing is connecting the 2 cubes the same way we connected 2 squares to form a cube. Boom, there we go. We can connect the inner points. And here we have our tesseract in what we call 4-dimensional space. So we have our tesseract, we have our cube, we have our square, and we have a line segment. And here we have higher dimensions and an easy way to visualize it. And we can even extend this to 5 dimensions. But I'm not going to draw it. 5 dimensions. But what is 5 dimensions in the Hypercube family? It's just 3 tesseracts. 3 tesseracts connected. These 3 tesseracts form what we call a 5 cube. And this can go on forever in the Hypercube family. A Hypercube family. This can go on for any number of dimensions, an infinite number of them. But I think this is the best approach to visualizing it. Another important point is what we are picturing here are one-dimensional lines that we drew on a 2-dimensional surface. My computer here, the plane, the canvas is 2 dimensionals. We're drawing on a 2-dimensional canvas 3-dimensional models of a 4-dimensional tesseract. Again, we are drawing on a 2-dimensional space using 3-dimensional models to create a 4-dimensional tesseract. And we can never view, as individuals with our eyes, we can never actually see if it exists, a 4-dimensional object from one single point of view. It is not possible to use our eyes to visualize a 4-dimensional object from one frame of reference. And with that, I think we can see you guys in the next video.